Hi. Thank you for welcoming me here. It's a pleasure for me to be at this conference. It's my only second conference, international conference, and by far the most high-profile one. So no pressure on my side. I'm also a burp guy, as you said. But nowadays I'm more into ZAP. But we'll talk about it. And if you have questions at the end, I'll leave time for those. So my background and who am I? I started a long time ago as a security engineer at the largest telco in Portugal. At that time, I was nothing close to a web guy. I spent the whole day doing TCP dumps and reading the Stevens TCP IP illustrated back to forth and reversing network protocols. Then I did a master's here in the States. I'm from Lisbon, Portugal, so a little far away from here. And in 2010, together with Nuno, which is here also, we built the web security team of Portugal Telecom. So they had no security team at that time for the web. They had a web division like Yahoo in the golden days with all those web products. And it was nice starting a web application security team with 2 people from scratch until, I don't know, more than 10 people. And in front of us, we had like 150 developers. So it was a challenge. I also was a pen tester lead at Cobalt, like a pen testing as a service company, you might know. But my current positions right now, I'm a co-founder and the CTO at Probably. So together with these cool guys, we just got our funding, our Series A funding. So it's going great. And full disclosure, Probably is a DAST scanner, a SaaS, so it's a cloud-based web application scanner. So, and the work, this talk will be based a lot on the work that we need underneath the hood, so we could scan at scale. I'm also, since maybe 2 months ago, maybe something like that, or 3, a co-leader of the Lisbon chapter of OWASP. This has been a long time dream of me and the other co-leaders, but we only managed to put it in practice recently. And we are having our first meetup in less than a month in Lisbon. And it's right before B-Sides Lisbon, so it's an awesome excuse for a 3-day security event in Lisbon. So go there, please. And this is also for me, it's a dream to be part of OWASP now more actively, because I would say my goal would be, and this it stopped working as usual, would be to have events as big as this. This was my first physical contact with OWASP, the OWASP Summit in 2011 in Lisbon. This was amazing. At that time, I remember having to find an excuse to go to the event, and the excuse we came up was to convince our employer to record and stream the event so we can get an excuse for OWASP to let us in. So we sponsored the streaming of the event, and this was great. We saw the birth of the Security Mobile initiative, and it was amazing to see all the browser heads of security sitting together to discuss and come up to agreements in how to do stuff. So awesome event. Hope it happens again. It would be awesome. That also the OWASP Summit in 2017, it was great. Also an amazing event. So objectives for this talk. The main objective is to share our scanning experience. So I've been scanning web applications first as a pen tester, maybe for, I don't know, 12 or 13 years. But in the last 5-6 years, doing more automated scanning at scale, scanning a lot of websites. So I also want to give some insights how to use ZAP to scan more and better. And of course, this talk is maybe a starting point for you to be able to automate and scan at large. Because there were a lot of talks in the days before, yesterday, that talked about automation and scan more, because we have like blind spots, applications that we don't scan. So I think we all agree that we need to scan more in an automated fashion. So hint, CI/CD, DevSecOps, constantly scanning everything. So I'll try to give some insights on how this can be implemented. So just also for you to define what it means at scale, at least in the context, considering my experience, it's about 150 scans started per day. Some of them take minutes, others take days, but scanning 150 scans, starting 150 scans in a single day, it's a lot. It depends on the context, but it's a lot. It's much more than anyone can do manually. Why OWASP ZAP? So I'm a burp guy. I use burp as a tool, like the repeater, the proxy. I started also doing pen tests with the scanner. But burp has some issues, and ZAP doesn't have those issues. So first of all, it's open source, so everyone can see how it works to its fine details. It also gives us a lot of flexibility, and the flexibility for me comes from being open source. It's good. It has the quality of the results are good. There are, of course, some issues. I'll mention some of them, but in the end, they are good. It's well maintained. It's well maintained at a point that I had to update this slide yesterday because they just released. Oh my God! I'm going to refrain from using the remote. Yeah, all that. So ZAP released the new version a few hours ago, maybe 16 hours ago. So this is great. It's well maintained. There's a team behind it with Simon Bennett. And we also choose ZAP because there's a lot of internal know-how. Actually, one of the developers of ZAP works with us. So he contributes to ZAP and we contribute to ZAP. So it made sense to use ZAP. So how do we use ZAP? So how do we scan at scale with ZAP? And this is a little bit of context on how we use ZAP in the ProWe context. So first of all, we use our own crawler. We don't use ZAP's crawler. We'll get to that in a few slides. So the talk will be more focused about the scanning part itself. So I know scanning has two big parts: crawling and scanning. So, and you cannot crawl and you cannot scan what you don't see. So your crawler needs to be good. But that could be a whole other talk. So we already had our spider. We were happy with it, and it supports weird stuff like shadow DOM and similarity detection and the duplication. So we decided, okay, let's not use ZAP crawler. So it was a conscious decision, just for you also to have an idea. So most scanners, or all the scanners, will report all the pages they find, like even if the pages are basically the same. And this is something that really doesn't scale if you want to scan a lot of web applications, because you know from experience that with a very high probability, these will be the same, just content changing. So basically, just let's skip it. Let's just scan one of those instances. And the same can be applied for the other URLs. So that's something that you might consider when you're scanning a lot of web applications, is that you need to figure out a way to scan as less as possible so you can scan as much as possible. So, but as I said, that's a whole other talk. So in short, we use ZAP only for scanning, only the scanning part. So it means we had to change ZAP to work with an external crawler. By design, ZAP works its internal crawler. So we need to receive HTTP requests from a third-party crawler, a valid session, metadata about the request. Is this the JavaScript request? Is this a login request? Is this a logout request? All these details can help you, if you have those pieces of information, can help you make decisions further ahead. So our scanner, our ZAP, scans everything it receives. With that regard, it's stupid. Everything we ask him to scan, he scans it. Of course, he needs to export the vulnerabilities that we found, so that's an easy task. And here, that's when the problems start. So ZAP, by design, first crawls, then scans. And that means a few things. It means we need to wait some time until we get our first results. And normally we don't want to wait, right? So depending on the sites, it can take from hours to days. Just out of curiosity, our crawls take the 90 percentile is 1 hour and a half. So actually, it's not that much time. But if you are thinking at scale and you want to scan a lot of web applications, you need to start scanning as soon as possible, so you can get results as soon as possible. So, but crawling and scanning in parallel might bring some issues. One of them is interface between the two of them. So it's rare, but it happens that the scanner or the crawler break each other work. So like the crawler is browsing the application and puts the application in a very specific state, like in a checkout state, but the scanner is already scanning a page that's further ahead. So this can cause some interference. Based on our experience, it's too rare to be considered a problem. So it's something that you can choose to completely ignore. Of course, there will be one application out of, I don't know, 300 that it won't be scanned adequately, but if we want to scan at scale, we need these trade-offs. So, and also an important thing to scan a lot of web applications is to have each target scan in isolation. So there's multiple reasons behind it. One is security isolation. So we are basically running ZAP and ask him to parse HTTP requests and pages that were created by third parties. So it will need to be robust because, you know, parsing text is a source of problems. And the last thing we want is to have a site that has an exploit that can break out of some specific context of ZAP and gets access to information from another target. So for security isolation, it's always good to have different instances of ZAP for each target, for each web application. It's also smart because of resources. So if you ever try to run a scanner, one instance for multiple targets, you know that the resources are not going to be enough because there's a lot of RAM usage and CPU, so it's better to keep them in isolation. And of course, this is easier to scale. You need to scan more applications, just fire more ZAPs. It needs to be fully automated. So if you want to scan at scale, you cannot have manual intervention. That's it, period. Even to recover a session. If it requires you to recover from a session lost, you are screwed. You will not be able to scan at scale. So the scanners need to be able to obtain and keep a valid session. ZAP does that, has a very good support handlers that you can change so they can grab the session and play it as you need it. And it needs to not have false positives. So this is a challenge. We have been trying to have we as an industry to report no false positives for ages, and we keep doing it because basically we want to report everything. We don't want to take the risk of not reporting something and then that's be explored and transformed in an exploit. So, and it needs to be resource effective. So, in the end of the day, ZAP is Java parsing arbitrary text from the internet. And scans take millions of requests. So, if you ever run burp or ZAP, it doesn't need to be a big site. If it has like lengthy JavaScripts or images, you'll immediately notice your CPU and memory graphs go up. So we need to be careful with this, and there's some details that you can be aware of that will improve your experience. So ZAP, you've probably seen it. I think there was a few workshop about ZAP during the event also. So quick overview about ZAP and how it works, really, really brief. ZAP has basically two pieces. The core, which is the part that manages the add-ons, and the add-ons itself. The add-ons basically represent the vulnerabilities. So the code to detect a specific vulnerability is typically an add-on. So we have the active scan rules, which can detect SQL injection, cross-site scripting. We have the log4 shell, also add-ons, and other add-ons. So there's the add-ons, and we have the core. The core handles everything else, like managing the scanning queue, managing the authentication, the output, input. And the add-ons, they have a very complete list. For those who don't know, they split the scan rules in like the maturity state. Like the first one is release level, so it's stable. Then they have alpha and beta. They normally work well, just the amount of false positives varies a lot. And it increases a lot as if you go to alpha and beta. So the default operation mode of ZAP, when you ask him to scan a target, is to place requests in a scan batch. So, and then for each scan batch, like a group of URLs, each active rule is applied one by one. So first, we'll scan for SQL injection. Then we'll scan for reflected cross-site scripting. Then for persistent cross-site scripting. Then for server-side template injection, whatever. So it's one vulnerability at a time for all requests. And basically, you can control how many requests are scanned at the same time. So how many URLs are scanned. So if you have a queue with 100 URLs, you can say you have like 10 threads. I'm air quoting because they are not real threads. They might surprise you. So you'll be able to scan 10 URLs or send 10 requests in each moment. And after this individual search for vulnerabilities, you have the bulk scanning. The bulk scanning only runs when you have all the URLs. So this is not very funny if you want to start scanning before the crawl ends, because you basically don't have access to all the URLs. So and that bulk scanning requires all the URLs to be at ZAP for the scan to happen. And in parallel, you have the passive rules executing. So like, I don't know, reporting for application errors and stuff like that. So the scan batches, imagine you have a target that has 10 URLs and you have configured ZAP to scan 5 URLs. This is basically what is happening. The 5 threads will start scanning the first 5 URLs, and then when the first URL is done, it will start on the 6th, and so on and so forth. This, of course, and very obviously, might lead to a situation like this where we have just a single thread running for the remaining URL. So in this scenario, we are not. So remember, we started with 5 threads, so 5 requests in parallel. At this stage, we are not doing 5 requests in parallel. We are doing one at a time, despite we having 5 threads configured. So this is kind of surprised me when I first started working with ZAP. And it can really slow down your scans. So the first question I would put out here is how many URLs should I put on my batch? So remember, I'm basically throwing URLs at ZAP, and of course I don't want to wait until I have all the URLs to start scanning. I want to scan immediately. So the obvious idea is, okay, let's create batches of one URL. So as soon as I have one URL in my at ZAP, I can start scanning. So one scanning thread, one URL, but this is not very good because if I have only batches of one, I'll be able to scan only one URL at a time. And of course, if I'm getting more, the others are getting queued, are getting blocked. So next idea, multiple URLs of one batch in parallel. So instead of having a batch with 10 URLs, I'm having 10 batches of one. So basically, I can easily increment the threads, and no URL will block others. But this is not really easy to do because this requires a heavy change to the core of ZAP. And this is something you not want to do. I don't recommend changing the ZAP core. This will take you a lot of work, and the ZAP development team is really active, so it will make your life really hard to try just to keep up with them and try to merge and rebase changes that they do. So, and there's also the issue of concurrent re-authentication. So if you have multiple batches running at the same time and all of them need to re-authenticate, you might have like a storm of re-authentication requests. Of course, you can manage this and not go to the login page every time, but it's really bad. So the most obvious solution is, okay, let's find out a reasonable number of URLs in a batch. So this was basically experimental. We did this, we came up with the numbers, which is not this one. We came up with the numbers by trial and error. We basically did a lot of scans with multiple variables and then measured the scan time. And we ended up with a few numbers that I'll show you ahead. So if we have 10 URLs at the same time, so a batch of 10. So ZAP will basically wait until it has 10 URLs to start scanning. It's a reasonable delay. Any crawler will find 10 URLs in an application in a matter of seconds. So that's not an issue. So let's start with 10. Let's start with also 10 threads. So, of course, this eventually will happen. I have a thread scanning an URL, and I might have like a queue of 200 URLs that are not being scanned. This basically, it's the same as this, which is how construction works, how construction goes in Portugal. One guy working and all the others, CPUs, looking at them, not doing anything. So it's exactly the same situation. So this is not the way to go. And if you want to speed up the scan, you have to figure out which numbers work for you. So these numbers, we came up with these numbers after, I don't know, scanning thousands of web applications with no specific type of web applications, just web applications that people ask us to scan. And this was the numbers we came up. So batches of 18 URLs. So it's a good trade-off between the time it takes the spider to find 18 URLs. So we don't have to wait longer to start scanning, maybe a minute or two. It's reasonable. And 6 threads. 6 threads is surprisingly small, but this is a speed trade-off. A lot of web applications simply don't handle more than 6 threads at a time. So it's basically the same as saying if you have 7 friends and you ask them to visit the site, they take the site down. Unfortunately, that's reality. I'm not sure how these sites live in the internet. Maybe they don't have a lot of customers. So basically, this number is a reasonable trade-off between not taking the site down, the target. If it's down and if it starts getting slower, you will get bad results. So this is something you have to keep in mind. If you put too much speed on your scanner, you'll take the site down. And normally you don't want to do denial of service. You are not testing for that. And that will mess up your results completely. I'll get to that later, but any payload that is based on delays and time will throw false positives like it's raining. So this was a good compromise, batches of 18 URLs and then 6 threads. And then if you have the time for that, you can add logic to increase and decrease the number of URLs, of threads, if the site is responding quickly. Yeah, go ahead.
Complementing that, have you had a look at throttles between requests, and did that cause any significant increase or decrease in productivity?
Yeah, that's actually something we had to do automatically, which is, and if I recall correctly, ZAP doesn't support that out of the blue. It's like a fixed value. So you can ask ZAP to have a delay between requests, but that's kind of a static value. It will apply to every request, which is great if you are doing manual testing of a single site. You can experience that and fine-tune the value. But if you do that at scale, if you start by defining that value, you'll see the scans taking longer, and it's very noticeable. Even if you just had a delay of 200 milliseconds, it's very noticeable because you need to keep in mind that you are doing millions of requests. So what we ended up doing, and it was not really, we ended up doing a few things, but one is to dynamically set a delay if the response time of the application increases after a certain threshold. So, yeah, and we also increase the number of threads if the application keeps. So actually, we immediately start increasing the number of threads, and we monitor the response time. And if the response time doesn't go up, we continue increasing. If it starts going up, we decrease. So that actually worked out pretty well, and only a handful of applications need a constant delay. Like UAT, test, QA, those are normally like a single core machine where all the developers are working. And you don't want to mess with the testing machine. You don't want the developers telling you, you broke my testing machine. So, but that is not something ZAP supports out of the blue. It's something, it's not trivial to add, but it works. So, but even with this, we still might have starvation because that group of 18 URLs, you might have 17 fast URLs and then a really slow URL, like right in the middle. So, and this can happen because it's a post and it has more requests and it goes to a different backend. We all experienced that. So what we ended up doing was to group URLs by response time and injection point. So the formula we use is not exactly like this, but it doesn't matter, just for you to have an idea. So we basically group real URLs that reply really fast and the ones that reply really slow. So basically, with that, we don't have like blocking. We don't have the slow URLs, like one slow URL, basically creating this situation here. So that could have happened if this URL was much slower, or like this one. So if basically we try to scan URLs that have the same response time, so all the threads are constantly working and no thread is blocking each other. So, and that actually worked out pretty well. This is really a simple, rough estimation based on the injection points. So injection points, it's a burp screenshot in a ZAP presentation. Injection points, and it's actually, I think, if I recall correctly, this is also a burp lingo. So one injection point, two injection points, three injection points, well, the most important ones. So a basic count of the injection points and a simple grouping, it's enough to make, to give you much better results. And I don't have like numbers here, but our scanning time increased dramatically, decreased dramatically, so it was much faster. So basically, we ended up with something like this. As we are receiving URLs from the spider, we are measuring its response time without payloads, and we are basically grouping them together in small batches, so we don't have to wait also for a lot of them. And this is more common than you imagine. Slow applications are much more common than you imagine. It's very common for us to start a scan, and an application that has a response time of like this immediately goes to 3 seconds. It's completely absurd. So the crawler, normally any crawler, sends URLs at random. So another strategy you might want to implement whenever you are automating scans and you are probably short on time is to prioritize authenticated requests. So this to say, don't forget to scan without a valid session, because you might have unauthenticated pages that reply differently, like the login page, of course, or the newsletter subscribe endpoint that reply differently if you don't have a valid session. So don't forget to scan those, but these are much more interesting. Scan those first. Also, requests with parameters are much more interesting than the ones without it. And by parameters, I'm also considering REST URLs, so you need to consider those. And of course, you can be also smart and prioritize requests with a certain parameters. Like if you have an order parameter or a page. I love the page parameter because everyone forgets to do tests to page parameters because no one ever wants to add enough content so the pagination appears. So pagination is great. I love to test the page parameters. They always break something. And of course, you need to be smart. and delay as much as possible testing. So basically put those at the end of the queue, destructive actions like delete. You can also do this with semantics, try to figure out if the URL, if the endpoint says something like remove, delete, destroy. You want to test those at the end, because if you first test the delete endpoint and only after the create, the delete is not testing anything. There's no objects there. So, and this is really important if you are scanning APIs. If you get a schema and you get all the pretty requests, create, put, the update, and then the delete. If you, by any chance, you're starting by scanning the delete, you are basically not scanning anything. And you won't imagine how many times I've seen that. It's very common. So authentication, it's something you need to handle. Of course, you can scan a lot of sites without caring about authentication. And I would say it's a good way to start. So the first time I tried to scan all the sites of my previous company, so I basically cloned their DNS. It was like 7,000 DNS entries. I'm screwed. So I went with small iterations. First, let's scan without a session. I don't care about authentication, I just care about what's public, and that's a good starting point. But if you want to go deeper, you need to authenticate yourself. So, and you have to be careful with some issues. So one that is not that common is to target does not allow for concurrent sessions. This can happen especially with more high-profile targets like the financial and banking. So if it doesn't allow for concurrent sessions, you probably cannot scan with multiple threads, and you might not even be able to use a crawler and the scanner at the same time. That can be an issue. It's easily solved by basically slashing the threads to one. So that's simple, but it's something you need to figure out manually. So there's like no easy recipe. There's also applications that are really annoying that detect any weird payloads and kills the session. Those most likely have a WAF doing that. So I hope the developers are not trying to do that by themselves. So most likely there's a WAF that detects a payload and immediately kills a session. I think we all manually scan applications like those are really annoying. And there's also idle and hard timeouts that the application might have that might screw your scanning. Or you basically call the logout endpoint and you kill your session. So you need to have some heuristics to figure out which endpoints terminate your session, scan them at the end, or do not scan them at all. Although I love to find open redirects on the logout request because it's never ever tested. And normally it redirects to the login page again. So there's frequently an open redirect there. So it's also something, that's why you must not forget to test the logout. And you need to test it with a valid session so you can get the redirect afterwards. So if you lose the session, you need to ask for one. And most importantly, you need to check if you lose it. So it might be tempting to check on every request if you lose the session, but to check for that, you need to do another request, or basically multiplying by 2 the number of requests you do. So, and that kind of works if you are doing manual testing. You can set up your scanner. That's really easy to do on Burp. To be honest, on Zap, I don't know if it's also that easy to say, go to this URL every time I'm going to test another URL and check if the response has X. If it has X, it means the session was lost, so ask for a session again. So a good trade-off, and it works, is basically only to check for if the session is valid after, I don't know, 50 requests, or 5 seconds, or 10 seconds. I know we might be losing visibility, we might be missing some vulnerabilities, because if we are checking every 10 requests and we lose the session immediately on the first request, the other 9 will just not test anything. But if you are scanning at scale, if you are doing automated scanning, if you are constantly scanning, this is actually not an issue, because eventually you'll scan that application again. Next week, next day, next month, I don't know. and the likelihood of you losing the session at the exact same moment is very low. So yes, today I'm not scanning that endpoint because the session was lost, but on the next scan, most likely I'll scan it. You might have some vulnerabilities appearing and disappearing, but that's okay. It's much better than doing this, checking every request. It's basically doesn't scale. So this is a good strategy to check every few requests if you are doing recurrent scans. It's something that works, basically it works. So other situations you need to be careful, of course. You don't want your scanner to change the password, otherwise the scanner will lock itself out, or remove privileges to the user. We all experience that, or delete the user, or delete the entire database. So this is something that you need to be careful. You cannot just enable all the tests, all the SQL injection tests. You need, for instance, to exclude the Boolean, is missing, it's here, the Boolean-based tests, because you're scanning way too many sites, so you cannot babysit the scanner, and you cannot try to manually exclude endpoints that do updates, and that might end up doing this. So it's a trade-off. You should disable the Boolean-based tests, otherwise you might end up with this. And I learned this the hard way. But apparently they have backup, so it was good. I tested the backup. So one of the biggest problems with scanners it's the sheer number of vulnerabilities that they report. Like, there's a lot of noise. There's the informational ones that actually no one cares. So yeah, you have an Apache, so what? You have a certificate, so what? You have a duplicate cookie, so what? The likelihood of that being significant, it's so low that no one has time to go after that and investigate, unless you are really targeting a very specific target and you are basically just focused on that. So you basically need to do compromises. You need to drop some of those. So the first is to drop informational. So the likelihood, and our snake was here yesterday, so he might not agree with this, because if you remember his cross-site scripting cheat sheet, like half of them would depend on this weird stuff that happened long time ago. But nowadays, these problems are not relevant. So MIME sniffing is much better. The browsers have better protections. So basically, let's ignore all of those. Yeah, I know this might give us some insight to something that it might be happening, but we don't care. We are basically just trying to scan thousands of web applications, so we need to focus. So let's focus on the more higher risk vulnerabilities. You also need to be careful with the amount of stuff you report. So if you have a page parameter vulnerable in all your pages, which is likely, it's not productive to report that for all the pages. Okay, it's nice to write a sheet of 100 red ones, but that won't help the developer and the guy that is fixing the vulnerability. So try to deduplicate vulnerabilities as much as possible based on the type, based on the parameter. And if you deduplicate too much, that's okay, because eventually the vulnerability will be fixed, and the other that you removed, the deduplicated, will reappear on the next scan. So it's okay if in one scan you ignore a vulnerability, it will appear on the next one. Also, overlapping paths, like if you have a directory listing affecting all of these, it's useless to report a single finding for all of them. Just report for the top level, the one that includes the others, and it's enough, because it's only one instance. False positives. So one of the most common false positives in ZAP, and also burp, so burp is not better than ZAP with this regard, it's the delay-based tests. So these scanners send a lot of payloads, like when testing for SQL injection, with payloads like sleep 10 seconds. And then they measure if the request takes more than 10 seconds, it's vulnerable. But it's really common for this to create false positives because the applications just got slow. Even with 10 seconds, applications easily get slow at a point that they take more than 10 seconds to reply. And if you get 5 of those false positives, it's bad. It's bad because everyone will be scrambling because it's a SQL injection and trying to analyze it, and in the end, it's a false positive. So you don't want to raise these false positives. And there are really simple techniques that can improve or reduce the number of false positives here. I guess the scanners don't do this, don't try to reduce the number of false positives here, because I would say, like, for instance, burp and zap are more designed to be used manually, not like in a large scale. So they probably prefer to have this to report the vulnerabilities and let the pen tester figuring out manually if there's something wrong. But if you are scanning 1,000 sites, you don't want even 50 false positives, because it will basically kill you. It will overload you. So one basic technique is to increase the payloads, the delay. Instead of 10 seconds, make it 20. And we tried that, and it barely improved anything. So the number of false positives barely decreased. The number of applications that got really slow and with timeouts was so high that that was not enough. So one of the things we ended up doing was to basically change a lot of ZAP rules to, instead of doing like the typical test is like do 5 delay-based requests or 3, and then 3 clean requests without a delay, and measure the time of the first 3 and then of the second 3. And the first 3 need to be slower. But even with that, we got a lot of false positives. So we ended up, okay, what are the odds of the first 3 requests being slow and the other 3 also slow and being a false positive? We thought, okay, let's just increment the number of measures. Let's do this 6 times. We'll send 6 requests with the payload and 6 requests without the payload. So what are the odds of 12 requests, all of them being slow? And apparently it's high, because we are basically doing the requests one after the other. So if the application is slow, 12 requests are not, they are requested in a very short period of time. So the application won't have time to recover, and all of them will be slow. So we ended up doing this. Interleave, clean, payload, clean, payload, clean, payload. And if I recall correctly, we had to do this 5 times, 5 iterations of this, until we could reduce the false positive rate to something manageable, something that would throw up like 1 or 2 each day so we can analyze. So, and this doesn't really slows down scan a lot, because I'm moving away from doing just 3 or 4 requests to maybe 6 plus 6, 12, or 8 plus 8, 16. So I'm doing, instead of 3 requests, 18. But the time you save not manually reviewing false positives completely outweighs the extra time it takes you to scan. So it's a good trade-off, actually. It's a very good trade-off. I think I'm running a little bit short on time. So for other vulnerabilities, it's also a good idea to try to extract an evidence whenever possible. So everyone knows if we see this in a response, the chances of being a false positives are really low, unless it's a documentation site, and it happens. So try to extract something try to take advantage a little bit of the vulnerability and try to extract something to make sure it's false. It's not a false positive. So it's really easy with vulnerabilities like this, a path traversal, to extract passwd file and then do some format matching, some pattern matching, and be sure that it's not a false positive. You also eventually will need to code some empiric knowledge you got. So when you start scanning a lot of web applications and you start to get false positives, you ended up with stuff like this, like findings saying there's a private IP inside the JavaScript file. So yeah, you can easily exclude this vulnerability for this type of files, but then you think, but what if I miss one? So eventually, after a while, you start noticing patterns. So this is a very common pattern. So, and it's really easy to code, to change the rules at ZAP. It's open source, so it's easy to avoid these false positives. And even if you don't want to do it inside ZAP, you can do it after. So if you don't have the knowledge or time to change ZAP, you can have like a post-processing, something that receives the vulnerabilities, and basically put your empiric knowledge there. The things you do manually when you look at the findings of your scanner, start doing rough scripts that basically filter out this garbage. So, and this really helps stripping out a lot of false positives. Oh, go ahead. Yeah. So I need to speed up. So a scanner, takes a lot of resources. It's not only bad scanning, so bad coding. It's also a decision. So ZAP developers made the decision of storing every single request for the last 5 batches. So you have a lot of requests in memory. For instance, Burp doesn't save in memory the requests with the payloads. ZAP does. So this is something you need to consider. And we have seen ZAP taking up as much as 180 gigabytes on disk. So for this, there's a really simple solution. ZAP has a defrag function. And basically, the defrag function does this. The disk usage drops a lot whenever you run the defrag function. You just need to be careful not to run it constantly, or basically the scanner will halt and you won't be able to scan anything. So do this on a best effort basis. You also need to be careful with regular expressions. There's a few ones that blow up when with these payloads. I think we already submitted 1 or 2 fixes upstream to ZAP. To be honest, we have like a pipeline of fixes to ZAP, but it's hard to submit things to ZAP. They are really strict about what they accept, which is good. And that's it. So ZAP, requires a lot of security knowledge and time, so it's not suitable for developers. It's true. No security scanner is really suitable for developers because of the false positives, because the time it takes them to filter out stuff. So if you try to be careful and scan only for the high-risk vulnerabilities and try to implement some of these statics to remove garbage, you might get a result. But these are trade-offs that you need to do. But, well, in the end, ZAP is a great base if you want to build something. So I like Burp. It's easy to use. It's a complete tool. But ZAP is great if you want to try something. So it's very easy really, to change and improve rules. So despite having a huge code base, the code base for a single rule, like a cross-site scripting is not the best example. But for, server-side template injection is small. So it's real easy for you to improve that and get better results. And that's it. I'm run out of time. Questions? Or more questions, because there were already a few. Sorry?
Was it 180 gigabytes for?
Yeah, ZAP stores like a session file, like the burp state file on disk. But because it saves a lot of the requests, like the last few requests it does, like all the payloads, it can grow a lot. It can grow. The record I've seen, at least that I noticed, was 180 gigabytes. Because you have a lot of responses from sites with JavaScript, with huge. Sometimes, if you are not careful, you ended up scanning images, which also takes a lot of time, a lot of space. So yeah, but the defrag function works really great. As long as you don't try to defrag every time, it works great. Or you could just throw a bigger volume at ZAP, and since the scan won't run for a long time, normally a few hours or maybe a day, you are actually not paying a lot.
A quick comment I wanted to make that I think might help because I've been in a similar situation where you're trying to reduce false positives from something else. And not specifically the SQL injection too, but like, you have a semicolon space, sleep space 5 semicolon, and that's a command injection mesh. And I would rather take the site offline and learn about that than miss that entirely, because that's usually a key on the One of the things that I've done in the past that works successfully is if you look at the default timeout for HTTPS responses on the server, like Nginx and Apache is 60 by default. I make my sleep 65. And the request either gets dropped or it actually waits 65 seconds. And then when you see it above that, you usually know you have something that's either binary. Yes, the site is completely offline because everything's synced out, or you got something that's working.
That's actually a good idea. It probably will get you good results. But it's also important, so I didn't differentiate a lot between time-based testing, between different vulnerabilities, but while implementing, I do. So for SQL injection, I probably, I know there's more payloads, so the likelihood of missing one with a delay-based payload, because I'm not doing properly testing with a delay base is kind of low because there's a lot of other payloads. And normally, if I have a SQL injection in one point, I also I'll get SQL injections in more areas of the site. For command injection, I would treat it differently. So I would probably do more attempts, and that's something we actually do. Most of the rules no longer do just one or two or three attempts; they do more attempts, and you're basically doing more requests to be sure, but that doesn't really increase your scan time a lot. Because you're only doing that for only a few of them, only the ones that initially trigger the potential false positive. So if you go from doing a command injection testing that does one request to one that does 5, you are not doing 5 requests for every parameter. You're just doing that for the ones that were a little bit slower. So in the end, you might do a little, I don't know, maybe 5% more requests. So it's a good result. But your idea also makes sense if you are able to figure out which web server.
You have to identify what the timeout is.
Yeah, sometimes it's not really easy, but yeah. But it's a good idea.